students, you know me, right? I am Ivanka teacher, and today in our science lesson, what are we going to learn? Okay, it's the same unit, unit number 5. It's a subtopic from Earth and beyond. All right, we have studied up to planets. You studied about the universe, you studied about the planets, and today we are going to speak about shadows. Okay, so with regard to the position of Earth and Sun, how shadows occur. About that only we are going to learn. Okay, so moving on to the first slide, children. What is a shadow? I always make sure to give a definition of what we are going to study, isn't it? So, shadows. Shadows are places where light is blocked. You already know that, isn't it? So, this is the sunlight. The source of light is given as the sun here. Okay? So, sun, see, shadows are places where light is blocked. The sunlight is coming here and it's blocking from, it's getting blocked due to this tree. Okay? So, because of that, we can get the shadow here. Alright? Okay. So, okay, the first point, a shadow is the dark shape made when something blocks light from a light source. Okay? And light travels in straight lines. Okay? Light travels in straight lines. Doesn't have any curves. Okay? It travels in straight line and stops when something blocks it. Okay? As you know, shadow is the dark shape made when something blocks light. Okay? The simple definition. Okay. Now let's go. These are the sources of light. Okay? These are the sources of light. Now look at this first one. It's a bulb. Okay? It gives us light. Okay? When we are in a dark place, my dear children, with the help of a light, we can see, isn't it? So this is a source of light. It's a bulb. And this is an oil lamp. Okay? And this is the sun, our main source of light, isn't it? So this is what you call a lamp shade, and this is a campfire, and this is also a light source of light. Okay? So we'll see. Now I told you earlier, light travels in straight line. See, this is a clear picture of it. You can see it travels straight in a straight line. Okay? So, how do shadows change? Now we are going to learn about that. So, since the sun's position in the sky during the course of the day, okay, during the course of the day changes due to the rotation of Earth on its axis. You know, Earth travels around the sun as well as it is spinning on its own axis. Okay, that is what I have mentioned here. Okay, the shapes of outdoor shadows as well as indoor shadows change. Okay, so the sun is not really moving, but rather Earth is. That is what I said earlier. Now you know, children, sun, when you talk about sun, it's rising from a different place but setting from a different place. So because of that, you must be thinking sun is moving around us. No, it's wrong. We are moving around the sun. Understand? So keep that in your mind, my dear children. We are moving around the sun, not sun. Okay? Sun is not moving around us. We are. The earth is moving around the sun. Okay? So here is a picture. You can see earth. This is earth. Okay? This is sun. This is earth travels around the sun on its own axis. Now here, look at this clearly. This is the sun and here it's going around. To complete this one rotation, okay, to complete one cycle, it takes 365 days. How many days? It takes 365 days, okay, which we call a year, a complete year. A year has 365 days, so which means for Earth to go around the sun, it takes, my dear children, how many days? 365 days. Okay? So now, when we speak about Earth, you know Earth is like a ball, which means it's a sphere. What is the shape of it? It's a sphere. Okay? And Earth is the third planet. You already know that, isn't it? It's the third planet in our solar system, and it's the only planet known to have life on it. You already know that. Okay? So Earth's axis does not run straight up and down in relation to the sun. It's tilted. Tilted in the sense it's slanted slightly. Okay? It's slanted a little. So because of that, as the Earth moves around the sun, while the Earth is moving around the sun, the northern part, okay, you know, north, south, west, east. So the northern part, the north pole is tilted toward the sun for about half of the year. Okay? And then during this time, the northern hemisphere, north pole is known as the northern hemisphere, it gets more sunlight than the southern hemisphere, which means the upper part gets more sunlight than the downer part. Okay, so northern hemisphere gets more sunlight. Okay, so during the other half of the year, now we spoke about one half. So during the other half of the year, the north pole is tilted away. It's tilted away. So what happens then? Then the southern hemisphere gets more sunlight. Okay, when it is tilted away, the southern hemisphere gets more sunlight. When it's tilted towards it, what happens? The northern hemisphere gets sunlight. Okay, so this is a picture. This is the diagram for it. See, the Earth is moving. See, this is the cycle. You can see. See, the northern, now when it's turning this side, this is the sun. See, the northern hemisphere get the sunlight more. And when it's turning the other side, what happens, children? Sun is coming to the southern hemisphere. Do you understand? Right. So Earth also spins or rotates around its own axis. Okay, you know, while it is turning around sun, while we are turning around sun, it is spinning on its own axis also. Okay, so Earth completes one rotation on its own axis, which means it takes 24 hours, which means one day. It takes how many days, children? In hours, it's 24 hours. It's one day. Okay, when the other half of the Earth faces away from the sun, for that part of the Earth, it's night. Now let's go to this point. You know, Earth completes one rotation in 24 hours. This is equal to one day. I already explained you. When Earth faces the sun. Now when we have sun, we say it's daytime or night time? Tell me. Now we have sun. Do we call that time night time? No, it's daytime, isn't it? So when the Earth faces the sun, this part of the Earth, it is day. We call it daytime. So when the other half of the Earth faces away from the sun, what happens? We call that night time. For that part, it's night. Okay? Right. Now see, this is a clear image of night, day and night. The sun is to this side, so the daytime comes here. To the other part, what happens? It's night. This is what I explained earlier. Okay? So you already know that position of the shadow depends upon the position of the light source. Okay? Position of the shadow depends upon the position of the light source. Now let's see. Can you remember we did this practically? The shadow stick experiment. In this we studied, this is the west, this is the east. Now we have put a stick here, okay? So according to the direction of the sun, the shadows also change. See? Now this is the shadow. These are the shadows, my dear children. These are the shadows. The shadow is long and points towards west. Okay, when it's 9 a.m., see 10 a.m., 11 a.m., it points towards west and the shadows are long. You can see. Now what happens when it's by 12 noon? The shadow is at the shortest length. It's at the shortest length around 12 o'clock. Okay, and when you go to this side, the shadow of the stick is long and points towards east. It is still long, but it is pointing towards east. These are the changes that happens with the rotation of the sun. So which means you can tell, my dear children, with the position of the sun, with the light source, the shadows also change. Okay, right. Now indoor shadows. When you talk about indoor shadows, I know you have tried this, isn't it? At your homes, you have tried this with your sisters and brothers. So this is also, my dear children, the same way. It is also, but the source of light is different. We don't have sun there, but we are using something else to create a shadow. Understand? Okay, so now let's talk about this person. Okay, let's talk about this person. Who is Galileo? He is a person, but he is a scientist. He is a scientist. Who is he, children? Galileo Galilei. He is a scientist. Okay, so he is from Italy. He is from Italy and he was born on 1564. Okay, and he is an inventor and a scientist. Okay, and he discovered the pendulum clock. Understand? Now do you know why I am talking about this person? Why I am talking about this scientist? Because he discovered the pendulum clock. Understand? Right. Now let's move on to the next slide. So this is the original drawing. Now look at this, children. This is the original drawing from 1637. That's the year. Okay? 1637. The pendulum clock designed by Galileo. This is the original drawing that he have designed. Okay, so Galileo's escapement is a design for a clock escapement. Understand? So he invented it on 1637 by Italian scientist Galileo Galilei. You know that. Now he discovered this. Galileo Galilei discovered this, and it was the earliest design of a pendulum clock. Now you must be wondering what is this. I will come to that. First listen to me. Okay. So since he was then since he was blind at that time, he was blind, unfortunately blind. What do you mean by blind? Which means we can't see. Blind means we can't see, isn't it? So he was blind by then. Okay, so because of that, he described about this pendulum clock to his son. Then he drew it. He drew the sketch. Okay, so after some time, both died. Okay, after some time, both died. So because of that, the first pendulum clock was built in 1657 from another person now. Okay, now, by Christian Huygens, who the first pendulum clock was built in 1657 by Christian Huygens. Who discovered the pendulum clock? Galileo. He discovered it, and his son drew the sketch. Okay, they made it out together, but the first pendulum clock was built in 1657. Okay, by Christian Huygens. Right. Now this is his son. I was talking about his son, right? This is his son, Vincenzo Viviani. Okay. Just look at the pictures. He is the person who made the first pendulum clock, Christian Huygens. Okay. Right. And this is a pendulum clock, children. Okay, it's an anticlock. Anticlock means it is, it comes from the ancient times. Okay, so which means, see, it's in 1930s. This comes from 1930s. See, the pendulum clock remained the world's most accurate timekeeper for 300 years. okay, until 1930s. So, for this only they managed to do the sketch, and this came out of their sketch. Understand? Galileo Galilei, he described the sketch to his son, and then they both were dead after some time. So the first pendulum clock was built by Christian Huygens. This is a picture of it. Okay, so now let's talk about sun. The sun is a star which is located in the center of the solar system. You already know that. Okay, so this is the sun, and what did Galileo discovered about the sun? Now here we are again talking about Galileo Galilei. He discovered, Putta, he discovered that the sun has sunspots. You can see these are the sunspots. Okay, see, this is the sun and these are the sunspots. Okay, okay. And shall we revise about what we have studied in our science lesson today? So we first spoke about shadows, okay, which means with regard to earth and sun, with regard to their position, how shadows occur. Okay, and then we learned about sources of light, which means campfire, sun, and then a bulb. Those are the sources of lights. And then we spoke about earth. We spoke about earth. We learned that not the sun, earth is moving around the sun, and it takes 365 days to complete one rotation, and for earth to spin on its own axis, it takes 24 hours, which means 1 day. Understand? Okay, and then we spoke about seasons. We spoke about seasons, we spoke about day and night, we spoke about Galileo Galilei and his discoveries, isn't it? And then the pendulum clock. Okay, so now I hope everybody understood my explanation and my lesson. Keep studying, stay safe, and thank you, my dear children.